Now that we understand how the first index law works, let's look at the second. Say we were looking at a question like this. So 9 is our base and 12 is our power. We divided that by 9 is our base, 4 is our power. How would we work out something like this? Well, our base is 9. How many times do we need to times or multiply 9 by itself? We need to do that 12 times. So 9 times 9 . So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's actually easier if we do it over, so when we're doing divide by, it's actually the same as if we do this, turn it into a fraction. It's easy to do this, and I'll show you why in a second. So now we're dividing by our base of 9 again, and we're multiplying it by itself 4 times. Why it's easier actually to turn this into a fraction is because when we're dividing a number by itself, like 9 divided by 9, it actually equals 1, so we can cancel these out. It makes this quite easy because we can just go by cancelling 1 from the top and 1 from the bottom. Now we see how many 9s we have left. So on top we have 1, 2, 3, 4, 5, 6, 7, 8. So we have 9 to the power of 8. And this is over 1. This is also equal to 9 to the power of 8. So we can actually apply a rule to this. So just like timesing two bases that are the same, we added the powers together. When we're dividing by a base, we can actually take the powers away, because 12 take 4 is equal to 8, which gives us our power that we got in our answer. So our rule can be, if A was our base to the power of x, divide by A, so remembering they have to be the same base, to the power of y. Our rule is A to the power of x, and we can take that by y. The rule can also look like this, because this is the same as our divide sign. So this is actually our second index law. Say we had a question. Okay, so first question here is A, our base of A to the power of 13 over A to the power of 10. So our working out should be A 13 take 10. What's 13 take 10? It equals 3. So our answer should be A to the power of 3. So that one's a simple one. But what about when we've got another base involved? Say we have A to the power of 3, B to the power of 2 over A to to the power of 2, and b, which is to the power of 1. Remember to draw in your 1 to remember that it is to the power of 1. So, what do we need to do? Well, we need to group our like terms. So our A's go together and our B's need to go together. So, our next line should look like A, 3, take 2, and B, 2, take 1. So, what's 3 take 2 is A to the power of 1, and 2 take 1 is B to the power of 1. We can also write this out as A, B. We don't actually need to put the power of 1 there, but it is just a good way of remembering that it is to the power of 1. Say we have a more complex question now. We have 9 times A to the power of 2 times by B to the power of 14 over 3 times A, which is to the power of 1, and B to the power of 9. So what can we do? We can group like terms. Is 9 and the 3 like terms? Yes, they are, because they're constants. We can work with these two. Our A's are like terms, and our B's are like terms. So our working out should look like 9 divided by 3, A, 2, take 1, and B, 14, take 9. So, firstly, what is 9 divided by 3? It equals 3. That's also times by A. And what is it to? What power? Well, 2 take 1 is 1. We don't need to put the 1 there, but we'll display that there. And that's also times by B. To which power? 14 take 9 is 5. So, our answer is 3 times A times B to the power of 5. Now you've actually understood the second index law. Thank you for listening.